I think that the whole area of digital rights management and security for software is also it's not a new area by any means, but I think that the fact that you've got sort of pervasive use of these virtual execution environments makes introducing standards in this space a much more viable thing for people to consider. Now, you can talk about a common execution format, whether it's Java or whether it's CLI format or what have you, and the fact that you're able to leverage a specification for copy protection or for intrusion detection or what have you over a large number of platforms, a large programmer community is going to make this a fairly viable thing to do. And of course, the safety guarantees that these VMs offer are a foundation for that. Next point is about hardware innovation. Again, this is sort of just beginning. The fact that we realize that by doing dynamic compilation, we now are essentially enabling more variability and more freedom at the hardware design level. One of the problems with hardware design typically is that you had to maintain a certain level of stability because the hardware was really part of the programming model for the developers of your box. And so you couldn't wildly change your hardware. You can't introduce instructions willy-nilly. You can't remove them. You can't change your microarchitecture radically because your developers are going to be surprised. And so the fact that you've now changed your programming model so it's essentially independent of the hardware platform or the operating system, you've given that much more freedom to the hardware developers to innovate. So as I say, this is just beginning. I think the hardware manufacturers are beginning to realize that this is an opportunity, that they can introduce instructions and they can be used actually shortly after the hardware is in the hands of their customers, as opposed to waiting until ISV or group of developers realizes that it's a good instruction and generating a specific version of the software and then testing it and then shipping it to you. Often it can be sort of a 2 to 3 year delay before some of these hardware features are actually realized and used by real users. And so that level of hardware innovation is just starting, I think. And the other thing is the whole area of hardware instrumentation. The fact that hardware can introduce all sorts of instrumentation that can be provided essentially free of charge to implementers or to the programmers. And that instrumentation can feed back into specializations on the basis of knowledge of cache miss behavior, knowledge of pipeline utilization, knowledge of TLB misses, etc. That all can feed back into even better optimization of programs and specialization. And the last point is high performance computing, which Vivek is going to talk about, which I think has been, for better or worse, has been an area ignored by VM manufacturers and virtual execution environments. Ignored, I think, mainly because performance is the #1 concern for high performance computing people. These folks will do anything for performance, right? And so if you put a couple of instructions in their way, they will knock you down, right? And they will get rid of those instructions. So on the other hand, as I pointed out, I think we're sort of on the cusp of introducing even better performance than could be achieved with static compilation. And I think that's a problem that we, as a community, want to break that dynamic compilation can actually take them beyond where they are now. It can better adapt to heterogeneous parallelism. It can better adapt to new microarchitectures, utilization of instructions. It can do specialization. It can do speculative parallelization, et cetera, et cetera. That's something that needs to be proved to these folks, and it's a hard sell, I can tell you. But I think that this is certainly an opportunity. So my key messages for this workshop, as I mentioned, the people in this room is sort of an intentionally eclectic mix. We're trying to see what will happen when we put people from very different areas together and discuss what is kind of a common concern. The other thing is I want to encourage all of you to kind of build relationships while you're here. If you're not already very familiar with the people that are sitting next to you or in this room, I think use the time that you've got available to get to know them, because the only way we're actually going to get these systems interacting effectively is if we have personal relationships to make that happen. The people that are driving the systems know each other and know each other's concerns and each other's customers. So that's really the one of the main of this workshop. It's an improvement for people. People are some of the best machines and execution environments that we've had, and it would be a shame if we couldn't learn from that experience as we go forward and build some of these new environments. And so, those relationships are critically important as well. Having said all that, I think being able to talk to each other and interact, we need to constantly be vigilant about the fact that we need to ensure that language designers and implementers have the most freedom possible to innovate, to create new virtual machines if that's what they want to do, or to use existing virtual machines and to innovate inside the implementation. So Mike already put up this list of people. I think I want to acknowledge them again. This was a pretty difficult job in a short period of time putting this together, and of course I want to thank all of you as well for responding on relatively short notice to the workshop invite, and I hope it's great for everyone. I do want to especially recognize Mike Hind, who really did almost all the legwork for the workshop. It just would not have happened without Mike, so thanks very much, Mike. Yeah. For doing that. And that's all I have. So any questions or discussion? As I said, my job here was to kind of set the stage and create a context for the discussions. I hope I did that, although I'm sure everyone here will add their own unique perspectives. Evelyn?
One issue you didn't discuss very much, virtualization. You talked about the cost of virtualization, but there's also the promise that the whole issue of porting software goes away. But in reality, that isn't really true. I mean, it doesn't really work that, a program that runs in one virtual machine runs on another one for the same language. So do you think there is a fundamental problem, or is it just that the virtual machines are not mature enough that this will go away and we will actually eventually eliminate porting issues?
Yeah, that's a good question. I think, the fact that we created a formal A specification that is independent of a hardware and operating system is a positive, but if that specification itself is operationally defined by a given implementation, we haven't really gained much, right? And obviously I refer to things like Java, but as well as to scripting environments today, that the specifications are far from formal by and large. And even if they were formal, we still have the problem of ensuring the integrity of the implementation of the specification. So no, I don't think that's a magic bullet. On the other hand, if you compare it to where we were, without virtual machines, we're much further ahead. So yeah, I acknowledge that's a problem. Dave.
I was curious to see your mention of digital rights management and security with VMs, because at least in my experience, if you wanted to decompile something with their bytecodes, obfuscated bytecodes to compiling source text in under a week is not a problem. And even these things that try to verify that they're assigned jar file, you cook up your own VM, you lie to it about the signature on the jar file, you're good to go. And, so it seems they really do compromise it rather much. And I'm not speaking in theory here. These are things we've done.
Yeah, no, of course. Yeah, I agree. The current practice is far from assuring DRM, but that's why it's on the opportunities chart and not the current problems. I think that there is an opportunity because you can have an environment where you can share a security context, right? And so you can actually prevent spoofing. But I think this is all very much in the research domain as to how we can ensure this. I agree with you. It's the current situation is a step backward.
Quick comment.
Louder?
VM used to mean something different than Java, like in the 1960s and 70s. So there, if you say, well, I want to assign something or something like that, they make a lot more sense. Like, look at security, application, and stuff at that level.
So, someone else? Go ahead.
So yeah, so I was curious that you mentioned interoperability and the alternatives is sort of having a one-size-fits-all like the CLR versus multiple different. So to what extent is the one-size-fits-all sort of not the most obvious common case, and then you have just kind of, I mean, you'd like to get as much as possible under one umbrella, it seems to me. So what are your thoughts about that?
Yeah, I think that's true, and to the extent that it's acceptable to the community of language implementers and so on to target one environment, I don't think that's a problem at all. And it's clearly the easiest solution that we can envision for it. On the other hand, I think we have to be cautious that it doesn't inhibit innovation. You know, that we have one specification with a set of assumptions that may not match language X that comes along in 2 or 3 years. And so I think it's very useful if we can devise a way for even, you know, fairly primitive interfacing, but efficient and usable interfacing between virtual machines, and make that part of the fundamental design point. It doesn't, you know, by any means remove the value of having something like a CLR, because again, it provides that much more facility to the language implementer, factors that much more of the runtime for them, and so it's positive, but it may not be the 100% solution.
So,
So,
yeah. I hope quick reaction about the impact on parallel programming and high performance stuff, which, you know, my take in dealing with, you know, those folks, I'm sort of one of them only occasionally, is that they don't want to change how they program. And, you know, if they would just program a little differently, they could actually win big. And I personally own the land speed record on some parallel benchmarks in Java. And some folks at IBM have had some experience on, you know, there's nice designs that work really well in high performance applications in Java. You know, the folks at Los Alamos, they won't touch them. So this is a culture and style and paradigm issue as much as a technical issue.
yeah, that's interesting. Actually, my experience is that they will go to extreme lengths in changing their
So long as they can
programming
do it in
paradigm.
Fortran. Yeah.
Fair. I mean, there's been wide adoption of C++. There's all sorts of things, but I think certainly with Java, there's been, I think you're correct, a cultural problem. You know, there's a historical problem where, and